Now we are going to study the rules to which we get abided in order to do the ray diagrams, the 6 ray diagrams of concave mirror. Even these rules are also applicable for the convex mirror and also for all the lenses. Now let us imagine let us take the case of first rule. This is the line, this is the incident ray which is coming parallel to the principal axis. Now what happens? Now once it gets struck, it comes back. The rule is when any incident light goes parallel to principal axis and falls on the mirror, it gets reflected through the focus. And you'll ask me why there is a hard and fast rule. This is not a hard and fast rule. If also we consider this part, the part on which the light gets struck, as a plane mirror, the normal passes with the 2f, and if we calculate the incident angle and the reflected angle, otherwise we calculate the incident angle and try a reflecting angle, if we make the ray pass through the reflected angle, it will pass through the focus. Similarly that of the convex mirror. This is the mirror, this is the incident light which is parallel to the principal axis. Now it should go through the focus, but here, as mirror is an opaque object, remember mirror is an opaque object, so it will try to get converged, try to follow, as if it would go through the focus, it will follow this path, but it will follow just the reverse path of this. So you will tell, is there any hard and fast rule? No. Let us draw the normal for this one and let us calculate the I and let us calculate the R. They will be same. So this is what the first rule. When any incident beam of light which will be parallel to the principal axis, they will fall on the mirror. They will go through the focus. They will pass through the focus or appears to pass through the focus. Like this, one appears to pass through the focus. Focus से ही निकला ऐसा पता चलेगा. Right? This is the first rule. Coming to the next rule. Taking the next one. Again, we have both of the mirrors. We have written F and 2F. Now the next rule states, if a beam of light passes through the focus. Okay. Now let us take another beam of light. This should appear to pass at focus. Suppose say this is what appears to pass from the focus. Right? This situation, when it passes through the focus or appears to pass through the focus, like if I extend this line, this will pass through the focus. They will reflect parallelly, as the parallel beam of light reflected through the focus, the reverse. If the beam passes through the focus, it will reflect parallelly. So how this will reflect? This will reflect parallel to the principal axis. And again, if someone need to justify it, just join the 2F, and because this was not parallel, join the 2F and you can be able to justify the I and R. Remember, the laws of reflection is also obeyed here. Here, if I am going to join the 2F, I am going to get, this is the incident angle and this is the reflected angle. The laws of reflection are also being obeyed here. The second law, if it passes from the focus or appears to pass from the focus in case of convex, so it will get reflected parallel to the principal axis, which is this one, principal axis. Okay. The last rule, but not the least, we are going to use this rule afterwards. I am going to explain to you. If the line passes, the incident beam of light passes through C, this is C and this is F, this is 2F and this is F. If the line passes through C, like if you have a beam of light which passes through C, this is the incident beam, right? So it will be the same way that light reflects. If it will pass through C, in the same way it will go. This is C and this is F. If you will make it like this, let us draw this one first so that it will be easy. And if a line is targeted to C, like this line, you can tell it passes through the C, it appears to pass from C, right? So if a line passes through the C, center of curvature, or appears to pass from the C, then the light gets reflected in the same path. So you will tell why? Because if you draw a normal in case of this small part of the mirror, then I will be 0. Then as I is 0, reflected angle will be also 0. This one also same. If you draw a normal, the incident line, the incident ray is grazing along the normal. So naturally I is equal to 0 and R is equal to 0. This is the third one, and this is the principal axis. So by using the three formulas, the three rules, if ray go parallel in the principal axis, they pass through the focus. If ray go through the focus, they reflect back parallelly. Okay, this is the reverse one. If they go through the C, then they bend back with the C itself. And if in case of convex mirror, it is also true. If you will tell any arbitrary, any angles other than this, then you have to do the normal method. You have to draw a normal, then you have to look for I is equal to R. With this, let us do the 6 ray diagrams. Let us